Okay, so we've talked about alcohols, we've talked about ethers, right?
Yes.
Mhm.
Okay, so here are examples of some alcohols, right? So you guys can see the methanol right there, and you can also see the butanol. See the chemical structure?
Yes.
And you also see the chemical formula, right? So again, the key, the OH, is the sign that it is an alcohol, okay? Now, if it's a hydrocarbon with an OH, it's an alcohol, right? Simple?
Yes.
Ethers, hydrocarbon, oxygen, hydrocarbon. So you'll see it written in many different ways. One is the very generic way. This is another way that is often written. And then this is the final way that it's written. So 3 different ways that it can be written. A lot of times we do it this way, like this, because it's a lot easier to see. Or like this, in this case, if they're 2 different hydrocarbons on each side. So then it'd be very easy to see, okay? Now, here's a very good example. So we talked about benzene. So here's a benzene ring. Now, when benzene forms a ring and it's a side chain, it's not the main structure, it becomes phenol or phenyl. You see it right here? P-H-E-N-Y-L.
Yes.
So you guys, we have an amino acid that has a phenyl ring, right? And so it's kind of important to know that benzene will become a phenyl ring. That amino acid also has a very unique smell associated with it because of the aromatic ring. What was the question? Am I making up questions?
Mhm.
Okay.
I think you're making up questions.
Okay, so I'm figuring, I'm sensing, maybe I'm sensing questions. I'm like, I'm feeling it coming. It's gonna come. Okay, so let's see. So we have a couple of other things to introduce to you. We have the aldehydes and we have the ketones. So the group that both of these guys belong to, get this out of the way. There we go. So the group that both of these guys belong to is called the carbonyl group, right? So the carbonyl group, pretty simple, right? They have a double bond, there's a carbon, carbonyl, right? You guys see it?
Yes.
Okay, now we have what we call aldehydes and we have ketones. You guys have heard of ketones, right?
Yes.
Okay. So the aldehydes basically just have that hydrogen attached to the carbon and then a carbon group, okay? So any carbon chain right there. So anytime you see a double bond, hydrogen on one side and a carbon chain, then you know that it's a aldehyde. If you have a carbon chain on one side and a different carbon chain on another side, or it could even be the same carbon chain, but you have carbon chains on both sides, the carbon and the double bond, then this guy is called a ketone. Piece of cake?
Yes.
Aaron? Oh, are you surprised I called on you? Is it a piece of cake?
Uh-huh.
Okay, so again, the best way of learning this is to put it on a card and then just draw them out, right? have them on the card. One side, say the name of the molecule, what it would be, and on the other side, have the structure, and just flip them over, you know, and that's the best way of learning these. You guys got that?
Yeah.
Yes.
Okay, good. So I'm going to keep adding more, right? Because we have 4 more slides to go over, and then we're going to do a couple of going through and see how much of it you remember. Now, there are a lot more functional groups, but I'm only going to give you a few for right now to remember, because I want to get you guys hooked on organic chemistry, so you guys come back and take me in when we get that class offered, hopefully in the spring, but we'll see. Yep. Okay, so we've already talked about cis and trans. You guys remember cis and trans? Trans means
Is it different?
On
They're
opposite sides?
Opposite sides?
Opposite side.
opposite sides, okay? And cis means
On the same
Same
side?
side?
same side. Yeah, or like saying trans is across and then cis, same side. So here we can also have it with just hydrocarbons alone. So because the double bond is rigid, we could have this situation where we have the carbon chain, if it's broken, yeah. The carbon chain on both, like both of these are just the methyl groups here. So they're on the same side. So that would be cis. Now, if they were across from each other, that would be trans. You guys see that?
Mm-hmm.
Okay, questions, concerns? Now, if you look here, this gives you a really great example, right? So this guy is 1-butene. This guy is cis-2-butene. This guy is trans-2-butene. 1-butene has a melting temperature of negative 184. Cis-butene has a melting temperature of negative 138.9. And trans-butene has a melting temperature of 105.6. Now you're asking me, okay, Dr. Henry, do I have to memorize those melting temperatures or those melting points? No, you don't. The point is that they're different, right? Although if we write their structure or we write their chemical formula, these are three different compounds. They're going to behave differently. So they're going to have different properties that are associated with them. And here, this clearly shows you that there are different properties with it. And this is why it's important to be able to name these structures. You guys get it? Matt, are you with me?
Yeah.
So my last thing that I want to go over is carboxylic acids. I said the last of our organic compounds I want to go over are carboxylic acid. Now, we still haven't talked about esters. This ester is just a hot mess. We'll say that for organic chemistry. We also didn't talk about amines, right? We'll also say that for later, okay? But I wanted you to be introduced to it. I want you to understand some of the basics of naming the structures, okay? Are you guys feeling comfortable?
I think maybe with some practice problems, I'll feel more comfortable.
Yeah,
Okay.
I'm writing all this
Because
down.
I'm trying to figure everything out likewise.
Okay. Okay, so let's finish with carboxylic acid, then I'll give you a whole bunch of practice problems, and then you guys can cuss me for a good minute, and then we have to start with the next part of nomenclature. Is that fair?
Okay. That's perfect.
Okay, so carboxylic acid basically has this group. So it's going to have almost similar to, let me find it. To our carboxyls or carboxyls. I'm sorry, carbonyls. I'm on a day right now. It has that double bond with the carbon. And then we have an O here. And an H. So it has a hydroxyl attached. Okay, so all carboxylic acids, do you guys, carboxylic acids, have you heard of those before?
Never.
Never. How many of you guys took biology?
I did.
You took biology? Then I'm
Yeah.
sure you heard of it then.
Okay.
Some of the most famous carboxylic acids are your amino acids. On one side, it has an amine. The other side, it has a carboxylic acid.
Okay.
So that's why we call them amino acids. So you probably have heard of it, but you probably forgot it because, you know, you went through biology pretty quick and, you know, you dumped everything out the door when you left, right?
Yep. Mm-hmm.
Okay. So naming carboxylic acids are easy. All you do is put ic acid. So I'm going to show you some carboxylic acids. And these guys, for the most part, they're going to obey that ic acid rule. But like, for instance, methyl, well, we call it acetic acid. Have you guys heard of acetic acid? So instead of calling it methoic acid, we call it acetic acid. Okay. So let me show you structure, and then you'll get it. I promise. I shouldn't promise. You'll be closer to getting it. Okay, can you guys see the structures on the screen?
Yeah.
So we have formic acid. Formic is when you have a, like for instance, formaldehyde, right? Formic acid is when you have an H over here instead of a carbon group. So you just have a hydrogen here. So that's going to be your form. So formic acid has an H instead of a carbon chain. And then you have C double bonded to an O, and then you have the hydroxyl group. Acetic acid, which if we went by the rules before, would also be called methanoic acid. Has one carbon, and that's attached to that carbon, double bonded to the O, attached to the hydroxyl group. But we know it as acetic acid. Do you guys know what acetic acid is? Anyone?
Is that the acetone?
It's not acetone. No, acetone is a ketone.
I have no idea.
Let me give you a hint. How many of you guys like salad dressing?
Wait, isn't it vinegar?
It is vinegar. Yes, acetic acid is vinegar. Right? And does that make sense with the ketone? I mean, acetone being a ketone, O-N-E.
Mm-hmm.
Yeah. And here, this is proponic acid. Okay, so why is it proponic acid? Actually, I guess this would be my bad. This guy would be called methoic acid, not methoic. This guy would be called methoic. That would be another name for it, but we go by formic. This guy would be ethanoic acid. And this guy is called proponic because you have 3 carbons. 1, 2, 3. Right? So we have to take that carbon into account as well. So if we have 4 carbons, what would we call it? So if we have this guy,
Would it be butanoic acid?
Butynoic acid, that's correct. So, and it would look like this in our line structure. Oops. So how many of you guys last night go and looked at your shampoo bottles? Oops. Or the chemicals in your cabinet to see how many of those that you could actually recognize.
I did not.
Come on, you have power now. You're not this little naive young buck. You know, you have power. You know how to read and recognize what chemicals look like. You should be practicing every day. I would go to the grocery store when I first learned this. I look on every bottle that I pass by. I'm like, well, I wonder if I know anything in here. You know, and I look on a label. I'm like, oh yeah, I can draw that structure, right? And then I go to the next one. I'm like, okay, and I'd write it down, and then I go home and practice doing that structure, right? Chemistry is always around you. Hold on. Let's see. Of course, I have to get the off-brand, and it doesn't list the chemicals. I have to go online to get them, but darn it. It's going to prove a point here. But most labels, they all have what is in it, right? The major component. And you should be practicing every day. You should be eating, peeing, sleeping, chemistry, right? Eating chemistry, right? Every day. Because it's always around you. There's always means of practicing, right? Are you guys eating, peeing, sleeping chemistry? Are you there?
Yeah.
I mean chemistry. I've been having dreams about chemistry. The Lewis structures, you know.
Okay, so you guys ready? We'll see if we can get this. Okay, so I've introduced you. I forgot to tell you, we talked about the names. Let me tell you one more thing about the names. Here. So aldehydes, we put Al at the end. Kind of like we did with the alcohols, we put OL for alcohols. For aldehydes, we put Al, okay? And then for ketones, we put ONE, acetone, right? So are you guys ready?
Yeah.
Okay. Okay, so, ooh, should we do a black screen?
That looks cool.
Okay, so let's see. Now, we're gonna do something simple first, and then we're gonna build up from there, okay? So, I want you to identify just the family. Don't worry about naming it right now. Just identify the family, okay? You guys ready?
Yeah. Kind of.
Okay,
I don't know if this is gonna sound like weird, Dr. Henry, but I don't understand like how like we name these. Like I understand how we went over them yesterday, but like when I see this, I'm just like lost.
why? Because
Like,
then we talk about, first off, determine the family that they belong to.
Okay.
Okay, so let's do that. That's all you need to do is determine in the family, right? And what was the rule? What is the first thing that you always do with every hydrocarbon molecule that you do? What is the first thing that you should do?
Carbon.
Count your carbons.
Count your carbons, right? Find your longest chain. That's always going to be the first rule. Okay, so don't make it harder than what it is. First rule, okay, what I always do, I try to figure out the family they belong to. I count my carbons, right? And then once you do that, we'll start going into the names. I haven't shown you how to go to actually in terms of the priority of the last 4 because I don't want you to worry about that yet. I just want you to be able to identify the family. The first ones, I wanted you to sit there and know the priority, right? Because I'm giving you bits and pieces. You understand, Ryan?
Yes.
So don't freak yourself out. Breathe, okay?
Okay.
Don't try to conquer the world. You know, just conquer your neighborhood. First off, do what you know how to do. Okay?
Okay.
Okay. Guys ready? I'm going to put you in groups. I want you to discuss it. And I want a very solid, confident answer. Okay? What we'll do is, let me take a snapshot of this so I won't lose it. Yeah, I have a picture of it. Okay?
All right.
Everybody took a picture? If you guys go to your annotate and hit save, you save a copy onto your computer. Okay, so you guys all will have a copy. Now I'm going to be visiting you, right? Each group, I want you guys to have one of those up on your screen. I don't want you guys working independently and then I want you to start discussing it and arguing it out and say, no, that is definitely a phenol ring, right? Or, oh, that reminds me, I want to add one more. No, I'm setting them up though. Okay, are you guys ready? Come on, smile. Selena, I want to see a smile on your face for once. There we go, that works.
Okay.
Okay, are you ready? Are you excited? Okay. Are you guys ready for the poll? So we'll go with each molecule. So, and then you guys can discuss with me where you think you're thinking.
Okay.
Now, did you guys argue a little bit?
They were just good conversations.
Okay. Well, good conversations can be perceived as by me and as an argument, so that'll work. I'll accept that. Okay, poll has been launched. Give me your votes. We're talking about A. You said you put all the clean ones where? Yeah, that's what I've been doing. On the side, there's one that has a whole bunch of them in there. Yes, I was putting all the clean ones in one. You could do that. Okay, this is a democracy. You must vote.
I guess it's a bad thing that I don't see my answer up there.
You said it's a bad thing that you don't see your answer up there?
Yep.
I mean, I see part of it,
Yeah, part of it.
but
Somebody read me the question.
It says, determine the family, oh, it should be determine the family of the organic, it's a typo, my bad. Determine the family the organic molecule belongs to. Say, determine the family that the organic molecule belongs to.
A?
A, we're talking about A.
Okay.
A.
Can I say it out loud?
No, you have to vote. We're only at 13 votes. There are 6 people who have not voted. You got to vote. Don't be scared.
she's driving, Dr. Henry.
Huh?
I said she's driving.
Oh, Judy's driving?
Yeah,
It looks like it.
Why the hell are
Be
you talking
careful,
to us?
Judy.
I'll see you tonight.
Judy was saving lives for 24 hours.
Don't kill anybody.
I'm going 60. I'm going real slow.
He's not pulling a Dr. Henry and going 90.
No, never. I'm grandma driver. I say that's. Can I say it out loud?
Yes, give me your vote.
Alkyne. Did you
Oh,
hear
do you want
it?
me to give you your choices? We have aliphatic, alkane, aliphatic, alkene, aliphatic, alkyne, alkyl halide, alcohol, aldehyde, carboxylic acid, ketone, ether, aromatic alkane.
I'm gonna go with the aliphatic alkyne.
Okay. Okay, so that gives me, we have 16 of 18, so that's 17 of 18.
Did you vote, Dr. Henry?
Oh, I guess I forgot about myself. Thank you. No, I didn't vote, but I have a vote, yes. So the answer is, let me end the poll. The answer is aliphatic.
Aliphatic alkyne.
Aliphatic. Hopefully I spelled that right. Alkyne.
Is he still asleep? Oh, okay.
Okay, and we know that because it's all hydrocarbons and it has a triple bond. The triple bond was our giveaway. Right? Triple bond. Y-N-E. Got it? Okay, let's talk about B. As in boy, you guys ready to vote?
Yeah.
Yes.
Yes.
Let me relaunch my poll, and you guys did pretty good. We had, what, 80? I guess it'd be a little more than 82% since Judy's vote was added onto it. Okay. Okay, we're at 13. We need there we go. There we go. Un más. Is Judy there? Oh, there we go. We got everybody. We got a complete vote. Okay, you guys ready?
Yep.
Okay, so 94% of you guys said it was a, let me show your in poll, show your results. Share results. I guess I should share the results. See, I have little issues with sharing if you can't tell. I'm the oldest. So 94% of you guys said an alcohol for B. And you guys are correct. It is an alcohol. Why is it an alcohol?
OH. Does the OH attached to it?
Because of the OH. So it just because it only has an OH, it's just the OH, that makes it an alcohol. You guys all know how to turn up, right? You know about your alcohol.
Yep.
Yeah, right, we do.
I love this class. You guys make it so much fun. Okay, you guys ready for the next one?
Yeah.
Yes.
Okay, I'm relaunching the poll. And we're talking about C. could have a really good brewing class using that yeast there. There you go. Hey, I could probably put that in my, we could start in our 1A class, which you guys started in fermenting, you know, for 1A. I actually got SCOBY, so we could actually also start. Yeah, I bought a packet of that. I just need to propagate it a little bit so that we can keep it going. Yeah, me too. Yeah, because man, I get a lot of unique flavors, you know. I wanted to try tomato. I want to try to make a tomato liqueur. So tomato, yeah, to use in Bloody Marys, you know. No, I didn't do it.
Amaya Isabella.
I do it in 1B. Yeah. What was that?
Sorry.
Okay, we need 2 more people. There we go. Come on. Are you ready? One more. Un más. Put your vote in. Okay. I'm going to share my poll. We only had 90%, 94% vote. Share the results. Okay. So what do you guys think? So it was a hot race. There are a few of you guys thought it was the ether. A few of you guys thought it was those ketones. A few of you guys thought it was carboxylic acid. We had one person that thought it was an aldehyde. The correct answer and the winner is ketones. It is a ketone.
Why is it ketone, Professor?
It's a ketone because you have a double bond and you have a hydrocarbon over here and you have a hydrocarbon on the other side. So that's your center carbon and you're attached to a hydrocarbon on both sides. So those guys are called ketones. Aldehydes would have an H on one side, right?
Okay.
Yeah.
Dr. Henry.
Yes.
So if there was a carbon between the double bond and then the 2 single carbons, would that be a carbonyl group?
No, it is a carbonyl. There is a carbon here. This is where a carbon's at. Remember, each point is a carbon. That's a point, isn't it?
Oh, okay.
Yeah, so that's a carbon. So that is a carbonyl group. But the carbonyl group is very general. Carbonyl groups actually have anything that's attached to a double bond falls under that carbonyl group. So technically, you have 3 possibilities so far that you've been introduced that have double bonds attached to them. This here, just a double bond and that O are considered to be carbonyl. You guys understand? The C and this double bonded O, that's carbonyl.
Okay.
So anything that has that would fall under that. That's a bigger family, right? It's kind of like, okay, for instance, I'm a Henry, right? That's my family. But there's a family beyond that family that got the Henrys together, right?
Right.
What was that?
I don't understand your metaphor.
You know what I mean? So I guess I don't understand my metaphor either. Okay, let me give you. So you guys know how you talk about animals, right?
Mm-hmm.
A dog. So there are German Shepherds. There are Chihuahuas. There are pugs. There are bulldogs, right? Aren't they all dogs?
Yes, they are.
Okay, so, but then if you go to pugs, right? There's the English pug. There's the Irish pug. There's the German pug, you know? So, but aren't they all pugs?
Yeah.
Right?
Yeah.
But aren't they all dogs?
Yeah.
Yeah.
Okay. So do you kind of get my analogy there? So you can get more specific, right? So we have ketones and we have aldehydes and we have carboxylic acids, right?
Yes.
They're all, you know, you have ketones, they're all different, right? There are differences between them, but they all fall under the family of the carbonyl or carbonyl. right? Because they have that double bond and that O attached to them. Okay, you understand? Just a hierarchy. Is that better?
Yes.
Yes, that makes a little more sense.
Okay, D. Are you guys ready for D?
Yes.
Yes.
Put your vote in. 61% of the vote. I feel like it's the elections. Who's going to be our next chemical compound of the week, you know? %. Come on, put that vote in. 83%. 88%. 94%. Come on. That one last one. Come on, you can do it. Cast your vote. All right, 100%. Excellent. So you got 100% of the vote. And you guys want to see the results?
Yes. Man, this is...
So D. So the correct
Ether.
answer is ether, right? It's not going to be an alkene or an aliphatic alkene because there's no double bonds in it, right? It has an O. Ethers have an O, and you have a hydrocarbon on one side and a hydrocarbon on the other side. So you are correct. The answer is ether. Welcome to the ether. Okay, so we have E. This is E right here. Okay. Oh, those are streakers. Loops. They call loops. Use the strict bacteria. Yeah, collect those, please, because they're expensive as hell. It's hard to believe that little piece of wire. Yeah, they charge $100 for a streaker. I'm like, are you on crack? Yeah.
What's $100, Dr. Henry?
Their little wire, it's a little piece of wire that's twisted and it makes a loop. And they charge $100. If you buy them from the chemical company, they charge $100 for one.
The
And they're like,
inoculating loop?
yeah. I was like, they're on
$100
crack. I can make
for
this.
that?
Yeah. You know,
That's
if
just
you
a
get the rod,
swab
you
on
have to get the
Petri
little
dishes,
rod that's
right?
attached to it, you know, but I'm
Oh,
like,
no.
they're on dope. I'm like, I'm not paying
Yeah,
that much
that's
for it.
expensive.
That's crazy.
I could borrow some wire for you for $100.
Exactly. I'm like, that's what I'm going to do. I'm going to have the students make it themselves. You're going to give them pieces of wire. You're going to make your own inoculating lube.
Start sorting.
Old school. It'll be a lab. You're going to build all your tools. Okay. I launched a poll. We're talking about E.
Well, I guess I did that one wrong because my choice isn't up there.
Likewise.
Mine either.
There's two ways of
Glad I
calling
wasn't
it.
the only one that thought that.
There's another way of calling it, of naming it. There's two ways, but this is the family name. The other way is more of an action.
Okay. Mm,
What size bag are you looking for? You need the small ones for the pH ones. Oh, I got you. Possibly. That size? So we're building kits.
You're making our kits after all?
No, your kits are on the way. I have to make a call to confirm that today before they go out of the office for the 4th of July. And I need to cuss some people too, but you guys don't need to hear that part.
yeah, I do. I want to hear that.
Be so mad. I'm like, we're paying top dollar for these damn kits.
Yeah, say some more. Get mad.
Okay, we're at 77%.
Oh, goodness.
Come on, gotta vote. It's okay to be wrong now. You want to be wrong today. You don't want to be wrong on the exam. Okay, 88%. Come on, 2 more votes. Put your vote in. 1 more vote. Come on, push that button. Push that button. It's that one. You know it is. Come on, you can do it. Let's go. Come on. Okay, 100%. All right. Polls ending. And let's share the results. So, E. Okay, what do you guys? It has Cl, it has F, Cl. What does that have? What are Cl and F?
Halogens?
They're halogens, right? Halide, hal. You see that one?
Aren't they also trans?
Trans would be the orientation, right?
Oh,
Okay.
So we
I
don't
was looking
call
for
them.
trans on the poll
Me
thing.
too.
That makes sense.
So if we named it, we would name it. It would have a trans in it, right? Because they're across from each other. We'll talk about the naming here in a second. But first, I want to get you guys to identify the family because that's the key right now. I want you to be able to identify the family, and I want you to be able to see that there's differences, right? And then the next part is getting really good at the naming, right? And if you guys get exposed to it now, most of you guys are gonna have to take OChem. I want you guys to do well because I think you can do well.
So who teaches organic chemistry now?
Who teaches organic chemistry now? Reedley and Fresno City. We don't
Not
do it
you?
at West Hills. No, we have it in the books. It's officially going on the books in the fall, but won't be offering it to 2021 because there's equipment that we need for you guys to be adequate at learning the whole organic experience, to get the complete organic experience, right? So we are lacking in equipment. You don't have the glassware, you don't have, or if we do have the glassware, we have enough for 1 person, right? And so that's not enough for you guys as a big lab to do it. And plus we're in COVID right now, so it's kind of hard to do anything. And this organic chemistry is one thing that you want to do in a laboratory because you're going to be boiling things all the time and isolating things by using heat and harsh chemicals. So you want to make sure that you have all of the safety equipment that is necessary to make sure that you don't kill yourself or kill your family or, things like that. So, guys, most of you guys do have to take it. And I think some of the nursing programs are starting to force students to take it as well.
Yeah, that's a lot of the programs. That's one of their prereqs.
Yep. Okay, you guys ready for your next vote? We are talking about F as in Freddy. Okay, so we're gonna relaunch. Oh, I guess I should put that one up. The answer. I know I'm blocking it, I'm sorry. I'll type fast, maybe not.
I don't know if that's right.
Okay, we're at 55%. Come on, get those votes in.
Oh, Dr. Henry,
Yes,
can you
sir.
can you post it? Can you post it in my screen, please?
Can I pause your screen?
No, can you post the choices so I can make the choices for the answer?
It should be there. Hit poll. It should be up.
Oh, there you go. Okay, there you go. Thank you. Which one we doing?
F, as in Freddy.
We already have.
F,
Okay, there
that
you go.
guy, right
Okay.
here.
You got it.
You said you left the key on the counter, right? Oh, up there? Oh, okay. Okay. And she's gonna text me when she comes.
Okay, we are at 94%. Last vote. Come on, put your vote in. There we go. 100%. You guys are getting good at this. Okay, let me share the results. So, which family does this guy belong to? So the correct answer is, if you did say here, so if you said aliphatic alkanes, that would be incorrect because that implies that they're linear or they're branching, right? If you said aromatic alkane, you are correct. So those ring structures, that's what cause your smells. Aromatic. Okay. G, are you guys ready for G?
Yes.
Yes.
We are at last tubes. Probably the ones I need to find the equipment to them because we're going to be making those. Not in your bags, no. No, that's for in the fall. So you guys are going to help me build my fall kits. Because this company I am not happy with. Hey, okay, we got 100%. You want to see the results? Share results. So G, you guys said carboxylic acid was the highest voted one, and that is correct. It is a carboxylic acid. How do we know it's a carboxylic acid?
Because it contains the carboxyl group.
It contains the carboxyl group. That double bond to the C and that OH, that's your carboxylic group. Okay, what about H? You guys ready?
Yes.
We got a new face in the building. They were probably here earlier and got bumped off. That happens sometimes. Okay, put your vote in. If you guys try to get the tight bags, don't get the big bags. So, because we want it so that it doesn't move around too much, because the more it moves around, the more chance it's going to break. So you want it to be firm, particularly you got to think about how it's going to be administered. We're trying to minimize our packing material. Limited. Yeah. Yeah. Yeah, and I have a few that we've broken in half by accident, you know, when we're taking them in and out. So we just need to melt those down, and I'll show you guys how to do that. I'll show you how they're made. Okay, one more vote. Come on, get that last vote in. Last one, last one. Okay, poll's ending. Let me share my results. You guys said it was an aldehyde. Oh man, you're right. It is an aldehyde. So why is it an aldehyde?
Because it has a hydrogen.
That's right. You have a terminal hydrogen here next to your carbon that's double bonded. Okay, let's look at this guy. We have I. You guys ready? Our last one. Dun, 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 dun. Get your vote in. Get your vote in. Hey, two more votes, two more votes. One more vote. Un más, un más. Last vote. There we go. We're at 100%. I'll share the results. And the answer is I. I is aliphatic alkane. Right? We know it's an alkane because it's all single bonds. There's no, it only has branching carbons on it, all hydrocarbons. So no functional groups. There's no OHs or anything like that. OH, if it's an OH, makes it an alcohol, right? So you guys want to pay attention to those structures. So if you're having trouble with this, it's on you because OH is an alcohol, right? So you want to make sure that you make those flashcards that have that OH. It has to have an OH in it to make it an alcohol. But don't confuse a carboxylic acid or an alcohol because a carboxylic acid has double bond O and an OH, okay? So we know that's a carboxylic acid, okay? Questions, concerns, cash, credit.
So Dr. Henry, it's only going to be aromatic if it's a closed carbon chain.
That is a good, yes, very good point. If it's a closed carbon chain, it's aromatic, right? We often will call them ring or cyclo. We know we put cyclo in the name when it's closed, right? You're completing that cycle. Questions, concerns? Down here so I don't cover it. Let's see, but okay, good. No questions, no concerns. Now you guys want to name some of them?
Yeah.
Okay, I'm going to put you in new groups. We're going to see how well you guys name. And then we'll come back and we'll discuss the names. Ready?
Yes.
Okay, so let's do a recreation. Feel like a god. You know, I'm recreating. Like, you guys aren't giving me the loving I need, so I have to get it from somebody. Why not myself? Okay, I think you guys are good. Actually, we'll do this. Actually, that's good. Doors are open. Have fun. Yeah.
Well, this was interesting. I'll say that.
The naming?
Mm-hmm.
Okay. So, who do I have a volunteer for A, or do I want to pick? We'll pick a group. So we'll go with the Jose, Juan, Kayla, and San Juana. San Juana, did you see that Israel had posted a little chat group or a discussion group that you guys can talk about with each other about questions and stuff?
Yeah.
Okay. And that's what you were suggesting?
Yeah.
Okay, I just want to be sure. Okay, A, who's gonna do A? You guys, group A, group 1. So group 2, we have group 2 is gonna be Alyssa, Karina, Judy, Rachel. You guys have B. Group 3. Group B, that's gonna be a little harder because we didn't discuss it so much, but I want you guys to give it a shot anyway, right? So group C, it's gonna be Deandra, Guadalupe, Matthew, and Ryan.
Okay. I'll write it in for us.
Group D, that's gonna be Aaron, Jocelyn, and Selena. Oh, actually, sorry. That's not going to be you guys. Wrong person. That's going to be Anna, Jessica, and Leslie. You guys are group D. Group E, that's going to be Aaron, Jocelyn, and Selena. And then we'll do all the last 4 together. Okay? Put your answers up, and then we'll discuss them. We'll fight, argue, till we come to some consensus. Okay, so we had pizza yesterday, so you guys have the option of Chinese. We could do Mexican. We could do subs. We could do burgers, mugs. We could do, what is today? Today is Thursday. Burgers or barbecue. It's a good day to eat.
Oh, on campus, at campus?
Yeah.
Invite?
Oh my gosh, that place is so good.
Yep.
I like seriously, when I go visit my mom in Kalinga, I like go and get
That's
that,
your spot.
the food there.
Oh yeah.
What
I love
Yes.
that.
this?
Oh, their tri-tip
Or
sandwich
patties.
on. Yeah.
I love fatties. Oh
So
my
good.
gosh.
Yeah. I love their tri-tip sandwich. So that's my
I've never tried their barbecue.
It is actually good. At least I
Is
think
it?
it is.
Are you
Yeah.
talking about pizza? The pizza place?
No,
Campus.
it's called the Campus Inn. So on Thursdays they barbecue.
Oh, yeah.
And
I've seen them
so-
have the
Yeah.
smoker out there.
Yeah.
Hungry.
They have a barbecue sandwich or a barbecue chicken sandwich. They have their tri-tip sandwich. You can get ribs, the rib platter.
So
I
they're
remember-
cooking on campus right now?
Not on campus. There's a little diner that is across the street from campus in
Okay.
Kalinga.
That's clean.
Yeah, on Thursday they grill, and
Okay.
so I always like going there on Thursdays. I was giving my sweatshop workers that's what it looks like. It does, especially with the mask and everything. It does. It just like that is the. I'm like, oh my god, I started a sweatshop. So
Don't be so hard on them, Dr. Henry.
what was that?
I said, don't be so hard on them.
I won't. I'll give them a minute break. You know.
Who's helping you, Dr. Henry?
It's Jessica, Israel, and Christian.
Okay.
Who's
Hi, guys.
Christian?
Christian is another one of my chem students. He's he keeps saying he's going to be a physicist, but he doesn't realize that he's going to come to the dark side eventually and become a chemist.
We know how Jessica and Israel looks like. Can we see Christian?
Sure. This is his sweatshop.
Hey, Christian.
Beauty's just out here making friends with everyone.
I know.
Hey, she's smart. It's called networking. That's
That's right.
That's how you get through life. Networking.
Right.
Can't be shy. Okay, you guys ready? Are those my answers? Ooh, that looks good. I'm liking it. Likey. 2, 3, 4, 5, 6. A is correct. Okay, guys, who's B? Group B.
That was me and
That was you.
Karina.
Where's that alcohol located at?
At 2.
At 2. So you need to tell me where it's at.
Oh, 2.
Yep.
Okay.
So you say 2?
2-butanol.
That's correct. Butanol. Give it an all. Remember, it's an alcohol.
Oh.
Turn it up. That's right. All. Oh, wow. Good job. That is really good. Group. So that is perfect. Only thing, pro. Yep, that's good. You guys are good. Okay, group 4. Group 3 is good. Okay, group 4. Let's see, we have methyl, 1, 2, 3, 4. Butyl ether. Good job. So D is right. Let's see, E. Let's see, trans chloro. Wait, is that trans 2-chloro?
Yeah.
Okay, so let's talk about this. You guys you're close. You're really, really close. So it would be trans 1,2-chloro, trans 1,2-fluoro, and then ethene. So, but you were really close. So you'd have to say trans because these guys are across from each other. So you're telling me where both of those chloros are at. And then you have trans fluoros, right? They're opposite of each other as well.
So we would have to write trans twice,
Yep.
like once for each of the halogens?
That's right.
Okay.
Because there's 2 of them. So it'd be trans 1,2-dichloro, trans 1,2-difluoro.
Okay.
Okay. So type that one up for me so we can see it on the board. So if somebody watched the video, they won't just, because they ignore what I say, right? They only watch what's on the board, so.
Are the videos uploading faster now, or are they still kind of a couple days behind, Dr. Henry?
They are very behind. So I think we've just completed uploading week 1 and part of week 2, and they are going to be available. I have to ask Israel, but I have a link for you guys. I have a channel. There's a Dr. Henry chemistry channel.
You got a channel?
I got a channel. Damn, I'm moving up.
Dang,
See,
you a star.
Israel is modernized our class, I'm going to start selling my services to other schools here soon.
Will they be posted to like YouTube, Dr. Henry?
Yes, you can go to YouTube. Yes, we have a YouTube channel.
So you're going to make money from the school and you're going to make money off YouTube. I see you hustling.
That's right. I'm a hustler. I told y'all. Okay. So, what was that? So you guys are getting this. I'm very proud. You guys are making me very proud. You guys are getting it. And you guys are helping each other, right?
Yes.
Yeah.
Mhm.
'Cause I know some of you guys are shy, or pretend to be shy, at least around us. So we're breaking that, right? Breaking that wall. Ain't that right, Anna? Anna knows she can't be shy anymore.
Yeah.
Correct, Anna?
Yeah.
Okay. So now we can move forward. Israel's here, so I could ask him. Israel, so do we have a link to our channel? We have to give them a link to our channel too. So we need to put under modules the link to Dr. Henry's channel.
You just gained a new subscriber, Dr. Henry.
Oh, excellent. We have a subscriber. We probably have our first subscriber. Hey, we're making progress. See, I told you, Israel is dragging me into the modern world.
So look,
You're going to be the next Melissa Maribel?
That's right.
you're going to play your videos.
Although hers are a lot more entertaining than mine, I just yell a lot, so.
Yeah, you got to get your nails done. In all of her videos, her nails are done perfectly.
Oh, I know. See, mine aren't. You can tell when I get up in the morning, I only do my hair. I just kind of throw something in it and we're on the road. Okay. So let's stop for a second and then. Okay, so. Very pleased, very, very pleased. So we're going to chapter 6. We're going to chapter 6, but I want to talk to you about chapter 6 first, right? Because when I talk to you and then you see it, then it goes so much faster, okay? Is that cool?
Yep.
Okay, so chapter 6, we're actually going to be talking about also inorganic nomenclatures. So we're going to have a couple of components. We're going to break it down. I'm going to go really fast in the beginning, then we're going to talk a little bit more. Some of it you've already done, right? Believe it or not. Remember we've talked about ionic compounds?
Yeah. Yes.
Yep. So you guys know how to establish an ionic compound. So let's talk about how we go about naming those ionic compounds, right? So let's start with that. If I can find my screen. So weird teaching from school again. I don't know what to do. Like I have a big screen up here and one behind me. Okay. Whiteboard. Okay, guys, can you guys see my whiteboard?
Yeah.
Okay, let's see how much you guys remember from ionic compounds. Let's say we have this guy. AL. Oops. Okay, AlO3, right? So the way that we'll go about naming this, right, since it's an ionic compound, and we know the charges. What is going to be the charges on the Al?
3 plus.
Positive.
It's 3+. And the O3?
2 negative.
Negative.
2 negative. Doesn't this guy balance out? Equal 0? So we have 2 Al, each one is a +3 charge. So +3. Let's do math. I know it's been a while, like a whole week. And then we have 3 minus 2. And we add them together. What does that equal?
0.
Zero.
Good. Good job, right? Simple, right? Simple addition, simple multiplication, piece of cake. Or simple addition in this case, but can be simple multiplication. You guys, you got that, right? So there's no big issues with it. Now let's talk about how to name it. Because we already know the charges and we know how many we need to sit there and make it 0, all we would do is call this guy aluminum oxide. Now, we don't say aluminum oxygen because it is a negative ion. So we want to use IDE, IDE, to represent that negative ion. Okay. Now we're also going to use IDE for other reasons, and I'll get to that point in a second. But right now, when we're talking about ionic compounds, that represents that negative ion. So we know that aluminum is going to be our positive ion, and the oxide is going to be our negative ion. We already know because they're defined charges that we have to give them that name. So, for instance, group 1 metals. Can I pull up a periodic table for you guys?
Mm-hmm.
It's okay. You guys have yours available too, right?
Yes.
Yeah.
Pull up my
Yeah.
periodic table. Okay, so we know group 1. Where's group 1 located?
Right where hydrogen's at.
Right where hydrogen's at. So group 1 metals, so that's from period 2 down to period 7. All of those guys will always be +1 charge. Group 2 metals, all of these guys will always be +2 charge. We know boron, and we know that aluminum is going to be a +3 charge. Palladium is going to be a +3 charge. These guys are going to vary. And palladium actually can vary too, but most cases it's going to be a +3. We know that carbon could either be +4 or -4. Same thing with silicon. We know that nitrogen is going to be -3. We know that oxygen is going to be -2. And we know fluorines and the halides are going to be -1. So these guys are all going to be -2. These guys are all going to be -1. At this point, we know that because we've been playing with them. We know that this guy is only 2 away from being a noble gas, so that's why it's going to want to get those extra electrons. So that's why it was important for us to understand that when we were doing electron configuration, right? So now that we know that, we can use that to our advantage for nomenclature, right? So we don't have to sit there and say a -1 this, or because we already know that oxygens are always going to be -2, right? Anytime you see an oxygen and a metal, oxygen is going to have a -2 charge, right? Now, there are some exceptions, and we will talk about those here in a minute. But for right now, that's what we know, right? Go with what you know, okay? So, but it's important for you to analyze and recognize who's the players in that compound, right? Because that's going to tell us so much. You guys clear with me on that?
Mm-hmm.
So
Yeah.
let me give you a couple of examples. I'm going to put a couple of them up, and I want you to tell me if they're written right, first off, and then secondly, what would be the name, okay? Whiteboard.
So did your AC end up working last night, Dr. Henry?
Yeah, you know what I did? So I
What?
called myself turning on my AC. I turned on the heater. So I was really having hot flashes. I was like, God damn it, why is it so hot in here?
Oh my gosh.
Yeah, it was bad. I'm like, and so I went down after class. I'm like, man, something is wrong with my AC. And I'm like, yep. Yeah, I turned on the heater. That was what was wrong.
Oh my goodness.
It was a rough night. Okay, so let me see if I can find where I'm going. Whiteboard. Okay, so we already talked about aluminum oxide. Let's do something challenging and get you guys involved. Okay, what about this guy? I'll put a couple up on the board, and then you guys will go through it. Okay? So let's start with this very first one.
Well, magnesium, doesn't it have a +2 charge?
Okay?
And then oxygen has a -2 charge.
Okay?
So would it be magnesium oxide?
Excellent. Somebody else. I love you, Ryan, but got to give somebody else a chance.
Of course, Dr. Henry.
Yep.
The next one is the same. So fluorine has a -1 charge and barium has a 2+.
Okay?
So it would be barium fluoride.
That is correct. Okay, somebody else?
Sodium chloride.
Were these the ones that you were saying were so easy
Yep,
on the Chem 101?
yep.
Potassium fluoride.
You should put some of these on the test.
There will be some of these on the test.
So these exact ones.
Yeah.
Is that one? Francium nitride?
I misspelled francium. Good. Piece of cake?
Piece of cake.
Yes.
Okay, so let's make it a little more challenging.
Oh gosh.
Oh Lord.
Okay, so this time I'm gonna give you the name, and then I want you to tell me the structure. And I want different people. You know, again, I love all you people that are active. I want some of those that are kind of shy, like Jocelyn. And, you know, I know Selena isn't shy, but she acting shy today, so.
I said they were.
And Aaron and, okay, so let me get some together. I'm gonna give you the name and you draw the compound. For those who are here, which ones are gonna give me their answers?
I can do it.
Okay. And there was consensus?
What do you mean?
Did you guys agree?
Oh, yeah, we did. So for the first one, calcium nitride,
Mm-hmm.
CAN, because
Mm-hmm.
calcium has a +2, and then nitrogen has a negative charge,
What negative charge does nitrogen have?
3.
Ooh, so you're telling me that 2 plus 2 minus 3 equals 0?
So it would need to be CAN2.
So CaN2, that's what you're saying. Now, calcium has a +2 charge? Is that right?
Right, and the nitrogen has a -3.
It has a negative 3, right? So
I'm
if I
already-
went CaN2, that would be 2 minus
Okay,
6.
so then it would be CA2N.
Ca2N. Okay, so let's do that. Ca is +2, so 2 times 2 is what?
4.
4. 4 minus 3.
1.
You're telling me that equals 0?
Okay, so we need this is 4.
So do you guys want me to put you back in the room?
I think the other ones are fine.
Okay.
Uh,
So you guys gonna let him burn all by himself? Y'all are cold.
All right, the first one
Yeah.
is a CA3N2.
Ca3N2.
Okay, yeah, it's Ca3 because you need 3 plus 2s to add up to the -6.
That is correct.
Okay,
Yes.
sorry.
That's all right.
And then the next one for aluminum carbide, it would be Al4C3.
Al4C3. That sounds good to me.
And then potassium phosphite would be K3P.
KP3.
Or K3P, yeah.
K3P. Okay.
And then radium sulfite is just going to be RAS because they both have a -2 and then a +2 charge.
Okay.
And then strontium iodine is going to be SRI2.
Okay.
Cesium telluride is going to be CS2TE.
CS2. Oops. TE.
Yeah.
Okay. Good job.
Thanks.
Virtual high five. Good job.
Thank you.
Yep. So everybody in your group got it? You feeling confident? Ready for the test? You're like, I could take that test right now. I got this.
Perhaps on this section, yeah. Yeah, I started practicing on the homework last night, so that's why I was.
That's why you're feeling confident. That's good. I'm glad that you guys are doing that. Yep. This is so much better than the other stuff. Yeah, the other stuff is a lot of memorization. You got to memorize. Okay, so this is what that looks like, you know, and it takes a little bit of time, you know, but once you get it, you'll be like, I got this, no problem. I own this.
Dr. Henry, are you going to be doing classes in the fall?
I am going to be doing classes in the fall. I will be doing, I know for guarantee, I'll be doing Chem 1A and Chem 2A. That's definite. I typically last minute, usually a week before classes start, I always end up getting a bio class. So it just depends on which one they decide to give me. So, yeah.
Do you usually do like 2 different classes, like Monday, Wednesday, Tuesday, Thursday, or do they just give you one option? Or
no, usually because I teach at 2 campuses. So I would do Monday, Wednesday at one campus, or like at Kalinga, and then Tuesday, Thursday in Fireball.
Okay.
Yeah. So that's usually how it's done.
Okay. Yeah, I'm trying to decide how I want to do my schedule this fall. I'm signing up for physics, and
cool.
I didn't know if I was going to be able to
squeeze
in
in
chemistry with you and physics there, and I want to be able to, you know, get my Mondays and my Tuesdays and all that organized. So I didn't know if you were.
Yeah. So you're going to be taking one. Are you going to be taking 1A intro? I mean, not intro, general chem, or are you going to be taking the organic course?
General, because this is intro.
Okay.
Yeah.
Yep. So you're going to be taking general. So either you'd be able to do either day. You're going to be doing it from where you're at. Is that correct?
Yeah.
From San Diego. So here's the deal, though. So for my 1A class, I'm going to have it set up so that basically once a week, you guys will get together to work on. There's 2 things that I want to get done for the fall. One of the things is a group project. And so you'll be coming in, just your group will be coming in at a certain time on the weekend. So it'll be once a month. You'll come in like Friday and Saturday. And what we can do, we could probably make arrangements. I have to talk to my boss. If they have the dorms open, we can make arrangements for you to have a dorm room during that time period if you're interested in doing that. So, but it'll be done like on a weekend so that for those people that would have to commute or come visit family to do it. But everything else is going to be done online. And so it's going to be, most of the course is going to be done online, but there's certain labs that we just can't do online because of the chemicals that we're going to be using. And it's one of those things that it's a must know for this class, you know.
Mhm.
So, and I haven't found a safe way of doing it at home.
Okay.
So just to be heads up, you know, but you know, it'll pretty much be gas money, and I'll talk to the campus to see if we can set something up like that for
Okay.
the students that'll be doing it online. So like a lot of business schools have this model already. They do all of their coursework is online, but they have their group projects that require them to be face-to-face and interacting with a company or something like that. So they'd come in, you know, for so many days on a month or so.
Oh, you already wrote the answers up there? Okay.
No,
Yeah, so-
don't get too anxious.
No,
We were
well,
just
I just
discussing.
looked it over, but yeah, that's what we got as well, me and my
Okay.
group.
Okay. No, I
Don't
just
think
wanted
I'm
to,
just taking your answers and running, Dr. Henry.
I know.
I was just comparing them.
You were comparing them. Okay, I see. Okay, so what we'll do, I had group 5 go up there and give me all their answers. So what I'll do is have all the other groups. Group 1, you guys do the first one. Group 2, you guys do the second one. Group 3, you guys do the third one. Group 4, you guys do the fifth one, or wait, the fourth one. I can't
I don't know I forgot what group number I was in.
Likewise.
Okay, let me tell you. So
I always get
I'll tell you the key
confused, sorry.
person. Kayla, you guys are group 1.
Okay.
Yep, or room 1. Karina, you guys are group 2. Anna,
Okay.
you guys are group 3. Aaron, you guys are group 4. And group 5, you guys, I'll make you put yours back up there again.
So we annotate your screen?
Yep, annotate my screen, make it pretty.
I don't know about that, but I can try. Let's see.
So we need some more medium-sized bags.
Ew. Oh my gosh. Sorry. Okay.
Oh, they're in a bag way over there.
Deandra,
Yes.
did he say we were in group 5? I'm like, I don't know.
I believe
I don't know which one we are.
Marina did it. I
Okay.
think potassium phosphide.
Okay, cool. She's got it.
I was like, you just said.
If there's a blank one, I know it's us, but apparently not. We got it. Somebody's
Yeah.
on top of it here.
Yeah. I kind of just listened to like the name. I didn't really hear like what.
Yeah.
Okay, anybody want to do the last one for me? Who's feeling rambunctious?
I do it.
Yes.
Oh, I'm impressed. Does everybody agree?
Yes.
Yeah.
Yeah.
I know you can't do the subscript with our typing in, but remember subscript, right? So for those who are looking on, you know those are subscript. Yeah, that's also a problem in Canvas when you're entering answers. You can't do subscript or superscript.
Mm-hmm.
So I need to figure out a way, find a way to make things work.
You just woke up.
Okay, who's gonna do the last one for me? Volunteer? Or
I'll
should
do
I
it.
volunteer?
I'll do it.
Like,
Okay.
oh, okay.
I wish Canvas or I wish Zoom would like tell you like in chat what group you were in.
Yeah. It's weird that they don't. I'll put that in their recommendation.
I know we come in, I'm like, what group were we in? All right. Okay.
Yeah, we got the same thing for that one as well.
That looks lovely. Good job, guys. Simple. Piece of cake.
Yeah.
I'm assuming.
Yeah.
Okay. Good. So let's make it a little bit harder.
Oh no.
Okay.
Okay. So the next thing that we're going to talk about are transitional metals. Remember I told you they're a hot mess?
Yeah.
Right? So transitional metals, we have to sit there and let us know what the charges are for those transitional metals, because they could be anything, right? So they're not always necessarily going to be exactly the same thing, like, you know, group 1, group 2, and where aluminum at, which is group 13, right? So the way that we do that is by putting a Roman numeral around them to let us know what the charge is. So for instance, if we were talking about iron 4 plus, right? So we would call this guy
FeIV.
Yep, iron IV.
Dr. Henry,
Ion. Yes, sir.
where do you get the 4 plus?
Well, so what's been determined is the different states, the different ions that iron can form, right? So iron technically can form iron 1, iron 2, iron 3, iron 4, iron 5, and iron 6. There are ones that are more prevalent. Iron 4 is pretty prevalent. Iron 2 and iron 3 are also pretty prevalent, meaning that they occur a lot of the time. And so the way that you know which iron ion that you're working with is by who it's paired with, right? So for instance, if I had Fe, see, you kind of set me up for this part. Good job. Look at that. If I had FeO2, what would be the charge on that iron for it to balance out?
2 plus?
4
2.
or 2.
Am I showing? What am I showing you guys? I'm showing the whiteboard, right?
Yeah.
Yes.
Yeah.
So go F2 and oxygen will be 4.
So that means that we would be working with Fe
Plus 2.
Plus 4.
plus 4, right?
Plus 4.
Plus
Yes, plus
oxygen
4.
holds a -2 charge, correct?
Okay.
Yeah.
So then the way that we would name this guy is. I can't find it.
4.
Where's my? Oh, there it is. The way we would name it.
Oxide?
What was that? Did it pause? Yes, it did. Resume. Okay. Are you guys there?
Yeah.
Yeah.
Okay.
Yeah.
So the way that we would name this is iron 4 oxide. Right?
So we need to learn Roman numerals then.
That's right. So you need to know your Roman numerals. You need to know your Greek prefixes for the next part that we're going to get to. And you also need to know your Roman numerals.
All
Okay?
right.
And it's important not to forget, you're using Roman numerals for transitional metals. Don't use Greek prefixes, okay? Roman numerals. Okay, so let's say we have something like this. Let's say we have, I'll type it out. Okay, what is that guy gonna look like?
So it'd be iron 4 plus, and then
And
wait, no, it's
Fe.
Has to lose 3.
Right here, Fe.
so it'd be FeN3, or
it wouldn't be balanced necessarily.
Fe. I hear Fe. Then what?
N.
Would it be the 4
And?
plus?
Okay, it has to be neutral. There's no plus. You got to get rid of the plus. You see, is there a plus over here?
No.
So when it's with somebody, when it's not the ion by itself, it has no charge. So you never want to do that. That's like slapping your hand. Remember, we've talked about that already with the other.
Mm-hmm.
So you got to remember, this is a building moment. We're building, right? So that means we don't want to regress. Okay, so it's FeN. Is that right?
Yes.
You don't put money on it.
Would it be?
it has to have a charge with it, though, doesn't it? It can't just be.
Would it be Fe3 and 4?
It would be Fe3 and 4 because it's not supposed to have a charge because it's a compound, right? If I put ion at the end, that means it has a charge. Do you see an ion at the end of that?
No.
Nope. So it always needs to be balanced unless it has the word ion on it, like this guy. You guys get that?
Yeah.
Okay. Now you say that, right? So I'm going to put a couple up here.
No, yeah, let's try.
Okay. So you want to try one more? See if we can get it?
Yes.
Yeah, try
Okay.
one more.
I like iron. We keep iron up, right? We're gonna put.
You spit up all over me. Yeah.
So let's say we have. I'll write the word. You tell me what we're gonna have.
I'll change them in a little bit. So
Fe.
Fe. Yeah.
Fe.
I hear Fe.
FeO.
And then
2.
O would have
Fe2. O3.
Fe2.
2.
I heard that. Fe2.
Oxygen 3.
O3.
Okay. So why is it Fe2O3? And are you sure about that?
I'm sure about that.
Because iron has 3. Okay, in this case, it has 3. But then we have to balance with oxygen. Oxygen has 2.
Yep.
So we have to balance that.
That is correct.
Woo!
Okay. You guys want to try one more?
Yes.
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 Judy, send your energy this way.
Honestly.
Take it all. Take it all. I'm about to crash after this.
Carbon.
MN.
So would it be MN C. We spot a 5 subscript after carbon. And then a 4.
That is correct.
Learn something today.
Okay, so let's do. Okay, let's do one more.
Right, that deserves like 4 Red Bulls.
I didn't have Red Bull this morning. I had a large, like 32-ounce cup of coffee.
Good Lord. My coffee's like a little bit of coffee with my creamer.
Really?
So it's just straight creamer that I drink.
Actually, I'm gonna change that. Hold on. Don't give me an answer.
Okay.
I'm like, or I normally will just do a nitro cold brew from Starbucks. Like that's my favorite.
Mm. Those are so smooth.
Yes.
Mm-hmm.
Okay.
So,
Balance.
we
PD3, and then you have phosphorus. Phosphorus 3 also.
So it's palladium.
PD.
So what do we call? I heard. What was it? Somebody said it.
Palladium.
Palladium.
Palladium. I don't know.
Okay.
However you pronounce that.
Yeah.
Is it palladium or is it palladium?
Oops, I misspelled it. No, that's palladium.
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 Phosphorus.
Phosphide.
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 So you just say palladium phosphide?
Yep.
You.
And that's it, I believe, for that one.
Maybe.
Yeah, because
Balance.
it's balanced.
Are you sure?
Phosphide has
No.
negative weight.
Well,
What was that?
phosphorus has a -3 charge.
Mm-hmm.
All right.
So,
Okay. 3.
But what about this one, right? What if I had this? What would I call this?
Did you pause?
or is that all you?
Wouldn't you just do PD subscript 3 in that case?
No, this is an element here. We have. These are two different things.
So in this case, would that be palladium phosphide?
So. Okay, you just told me that they're both palladium phosphide. Is that true? Can they both be the same? Aren't they different from each
No.
other?
They're
Yes.
different. They're different.
Yeah.
Are you
they're-
guys forgetting something?
Oh,
What's
the
the
Roman
major thing
numeral.
about transitional
The
metals?
numeral.
Oh, my Roman numerals. Man, you see what I mean? We're supposed to be progressing, not regressing. Come on.
Oh God.
Yeah, it'd
You're
be
gonna stand in
palladium
the
and then
face,
the
right?
3, the 3
here
Roman
we go.
numerals, and then the phosphide.
Okay.
Thank you, Lupe.
Should you put it in the chat or something?
Yeah.
Yeah.
Oh,
Dr. Henry,
Yes.
I'm a little lost. Can you show me how the Fe2O3 was made?
Sure. Give me 1 second. Let's finish with this one first, and then we'll go back to that.
Okay. Come on, let's change you.
Okay. So what would be the Roman numeral for this one?
3?
3.
Okay. Piece of cake.
That makes more sense now.
Okay. Don't forget your Roman numerals for transitional metals, although there are exceptions. Okay, so let's talk about this iron 3 oxide. So this is what was given to us, right?
Yeah.
Okay, so we're given iron 3 oxide. I'm assuming that was Jamie?
No, that was me, Rachel.
Rachel, I'm sorry, Rachel. I can't see everybody who's on the screen, so. Okay, Rachel. So what is the charge on that iron?
It's 3. Is it +3?
It is a +3. So what I do, so I don't make bad mistakes and put it together, so I always put it somewhere on the side to remind myself that it is iron 3. But I put it on the side because I know that when I write my final answer, it doesn't have charges associated with it. Okay, what is the charge on the oxides?
-2.
So, and if I'm putting both of them together, I know that it has to equal what?
0.
0. So how many oxides will I need to balance out the irons? So, for instance, right now this is 3 minus 2. What does that equal? Does that equal 0?
No.
No. How can I make them so that they're equal to 0? How many irons will I need? How many oxides will I need?
So for iron, we would need 2.
I'll need 2. And then oxides, how many will I need?
Okay.
So right now, that's 6. And we have 1 oxide. So how many of these will I need to make it 0? So right now I have -2, so that makes it 4. So if I want it to be 0, what do I need to also keep adding? How many more?
We're not good. Okay. So 6 minus 2 equals the 4. And then,
That equals 4. Does that equal 0?
no, so we would need, it would be we would do -4 to get to 0.
Okay, how do I make it -4? How many oxides will I need to make it -4? If each one is -2.
Oh, okay, I would need 2. Well, I would need 2 oxides.
You would need 2 more oxides in addition to the one that you already have, right?
Yeah.
So that's. Okay. So how many oxides do I have here, Rachel?
You have 3.
3. 1, 2, 3. How many irons do I have?
You have 2.
2. Fe2.
Okay.
O3.
Okay. I need that. Okay. I'm going to just take a picture. Thank you. I get it.
No problem. Yep, that's it. That's all it is. It's just either you can do it by multiplication or you can do literally. When I learned it, it took me a while to understand that, oh, this means that I have 2 of those and then 3 of these, and okay, that balances out so that I have a total charge of 0. All right, so I literally had to write it down like that for me to start clicking, and then the multiplication kicked in, and then,
Okay.
Okay.
Thank you.
Okay, you want to give another shot? One more?
Yes.
And then I'll let you go.
Sounds good.
Sure.
For now. Okay. Oh yeah, we're gonna give you a good one. And we'll talk about the exceptions later, but right now I just want you to work on, I'll give you 2 more. So let's do, are you guys thinking?
Yeah.
You just got real quiet, I was worried.
Would it be nickel bromine IV?
So you're saying nickel?
It'd be nickel IV.
Nickel IV. Okay, because we put it right after the metal.
Oh, right. Well, it'd be IV because V is
IV.
5, isn't it?
There we go. IV.
Bromine.
Bromide. Okay, what about this guy?
would it be rhenium?
So this one would be here.
Vi silicide or silicide?
Silicon.
Oops, wrong eye. I'm in the wrong spot. Hold on. Simple.
Simple.
Okay. Are you guys feeling confident? You can take the test right now and ace it.
Oh yeah.
No. No way.
No.
But you're getting there, right? You're feeling a little more confident than you did yesterday or the day before
Yes.
or the beginning of the semester, right?
Yes.
Yeah.
So do you guys feel that you're learning?
Oh yeah.
Yes.
Good. So I will see you guys. I'm going to say, I'll see you guys tomorrow.